Hi everyone, Miss Martin here. I'm sorry we weren't able to have any live chats today. I have meetings all day, but your assignment for today, which is Wednesday the 20th, is to complete this Edpuzzle. Okay, so our goal, I can explain how stored energy determines moving energy. We're going to take a look at the connection of how much energy you have stored up equals how much you're able to move, or an object is able to move. So let's review Monday's assignment. What was similar about both roller coaster designs? Both designs start with a high hill. So for the prediction statement, why do you think the first hill is always highest? After watching the video, you should have realized that it gives the ride the energy it needs for the roller coaster to make it to the end. In Doug's experiment, why didn't the marble make it over the higher hill? The problem was it didn't have enough stored energy. Since the second hill was higher, it uses up all of its energy trying to get up, and then eventually it falls back down. What happened in the bowling ball experiment? When the ball was let go, it never made it back to its starting point. And where does the roller coaster get all of its energy? It gets all of its energy from the highest hill. So let's take a look at these two types of energy. Last week I talked about potential energy, which is another word for stored energy. The other type is kinetic energy. So potential energy is energy stored, like in height. So this picture on the left, as it's reaching the top of that hill, it has stored up a whole lot of energy because of how high up it is. On the right is a picture of the roller coaster in motion. It's moving downward and it's able to glide along those rails because of all the energy it stored up from that first hill. So with kinetic energy, just like in this picture of the girl in the swing, she is pushing and moving, and that's energy that's in motion, that's kinetic energy. For the second picture, we have potential energy. So it has stored up all the energy it has by driving to the top of the hill. That gives it the potential energy, and then as it slides down the hill, it uses kinetic energy, energy of motion. Another example here, we have the boy riding his bike up to the top of the hill. That's the potential energy at the top of the hill. And if he doesn't have to pedal, as he rides down because he's letting all that energy out. And then in this example, we see the girl holds the ball at the top. It shows potential energy there. And then it transforms, or it changes into kinetic energy when she lets the ball go. So all of these things are examples of potential energy stored as height. One of the major laws of physics is that conservation of energy. Energy can be neither created or destroyed. It can only be transformed or transferred from one form to the other. For example, if the gas in a car is stored energy, it only has the ability to move until all that energy is used up. Once it's used, some energy is given off as heat, some is given off as the sound of the car, and some is given off through the exhaust. And all those things are the energy transforming into heat energy. When a car is out of gas, potential energy, it will not be able to move. No kinetic energy. So the amount of stored energy it has, just like in the gas tank, lets you know how far that car can travel. Just like the car, the big hill at the top of a roller coaster stores all the energy the ride needs. It cannot use more energy than it has stored. And once that energy is used up, the coaster will stop and it will slide into the little house at the back. So in our bumper coasters experiment, we tried out a few different varieties of balls and where they would possibly both make it into the ending point. So the one big hill gave the energy for the entire coaster. The energy was transferred. It wasn't lost. It was transferred from one ball to the other. Also, if you've noticed, as it went down the track, since it was pressing on the track, some energy was lost in that friction of the ball pressing on the track. The only time both balls reached the end was when it was placed on the low hill. Why do you think that is? So if you take a look, the only time it worked is when it was placed on the low hill. So that gives it a little bit of extra potential energy. And then at this point, the high hill ball has been rolling for quite some time, and it is able to hit that one without losing too much energy. And both of their potential energies were stored through height. Having the second ball on the hill also gave it potential energy. Both balls had enough potential energy from both hills to make it to the end. So when we are done here, I want you to answer all 3 questions and then hit the turn in button. Thanks, guys, and if I don't see you tomorrow, have a really good Memorial Day weekend.